everyone, and welcome back to a YouTube video, the first in about 2 months. And in today's video I'm going to show you how to make a simple single player Pong game in C++. So I've decided to make this one quite nice and simple for everyone. You're not going to have to fiddle around in Visual Studio trying to set up SFML, which is the library we're going to be using to actually write the game. So there you go. So if I come to my GitHub page, which is just github.com/jake1402, I believe it's on my YouTube front page, but I'll also link it down below in the description. Just click on repositories, go to single player Pong. Once you're on here, click on this bit here to select a new branch and do the code along setup. Then it's super simple, you just go down and then click download in zip, or probably even open Visual Studio. Let's do that one. Oh, no mind, let's just download it. And then you just want to click extract all, extract, place the files in the destination if it'll allow me to. Yep, sweet. And then simply just click on the SLN file. It's going to take you into this screen here. If you don't have Pong, if you don't have this screen here, just do this. Drop down here and then go on to source files and just open it like so. So the first step we're going to do actually is we're going to just check everything's working fine. We're going to do it by going into SFML. I'll link this down in the description, the tutorial part. And we're just going to make sure everything has imported properly by copying and popping that into there and giving it a good run. And then click it. There you go, successful build, and we got a green circle, which is perfect. So the first step in what we're going to do, actually, we're going to import our libraries. I sound god-awfully British then. So it's very simple. All we need is just 2 SFML libraries. Extensions, whatever they are, I've lost it. Packages, I guess you could say. We're going to include IOStream for just helping us with some debugging. We're going to include SSStream, and this is going to be used for converting some numbers into strings for us. We're going to include functional, which we'll be using for our threading, as we want to include some threading in here. And finally, we're going to include the math module. But don't worry, there's not going to be too much maths involved in this one. There we go. So what we're going to do now is we're just going to set up the paddle and the ball. So I'm just flipping through my notes here just to make sure I've got everything. So what we can do is we can get rid of this, and we can get rid of that at the moment. In fact, what we're going to do is we're going to put the ball in here because we want to generate the ball first. So actually, I didn't mean to delete all of that up there, that's my bad. There you go, so we're just going to get rid of that and pop all in here, as we still need our window. But what we're going to do is we're just going to get this bit up running, so we're going to type in srand here, we're going to put in time, and we're just going to put null. And what this will do, this will allow us to generate random numbers more efficiently and effectively. If we don't do this, we'll basically be seeing sort of repeating patterns in our sort of like velocity generation of the ball. I know it's all a bit confusing at the moment. I'll explain as we go through. Another thing we're going to do, we're going to set up Vsync. So we're just going to do window.setVerticalSync enabled. I'm going to type true in there. And then finally we can start programming the ball and the paddle. So what I'm going to do is I'm going to do SF. This is going to be the paddle, rectangle shape. And we're just going to call this paddle. Yeah, we'll just call it paddle for now. I'm going to do SF, and inside here vector 2f, and this is going to be the width and the height of our paddle. So what we just want to do is we want to do 30 and 100 for the dimensions of the paddle. We're going to do paddle again, dot set fill color, and we're just going to make it the color white, so SF color white. And then we're going to do paddle, and this time we're going to be setting the position, set position. It's going to take in another vector. A vector, if you don't know, simply put, is kind of like a list of numbers. So this is a two-dimensional vector, so it's just got an x and a y component. It's as simply as I could put this. So for the position, we're going to do 920 and 400. And just before I do that, I just need to make sure I've set the correct dimensions for the window that we're going to render. So just looking back at my notes here. So yeah, we're going to set it to 1000 by 900 for the window. And once again, that's going to be the width and the height of the window. It's kind of like, it's quite squarish, but it's actually rectangular. And then the next thing we're going to do is we're going to set up the circle, or the ball. And to do that, we're going to do circle shape, ball. And then this one's just going to take a number, and we're going to make it 10. That is 10 pixels. I'm not too sure if it's diameter or radius. I want to say radius. So I'm going to stick with radius. So that's basically 20 pixels in diameter, I believe. And then just beneath this, we're going to do ball.set fill color. And we're going to set the color to white as well. And finally, we're going to set the position. It's just going to take another vector, just like before. And we're going to give it a position of 200 by 450. And then finally, we're going to draw the ball. And we're going to draw the paddle. And if we run this, we should hopefully see a ball and a paddle. There you go, so there's our paddle and there's our ball. Lovely jubbly. Just for fun, we're going to name this Pong SFML, but you can name it whatever you'd like. Now, what I'm going to do now is I'm going to create some global variables, and a global variable is just a variable that can be seen any part in our program here. So we're going to create three global variables. We're going to create a points, which is just an integer, and that's going to be 0. We're going to create a maximum velocity, but I'm going to call this max velocity mag, and that just stands for maximum velocity magnitude, and that's because our velocity is actually going to be in a it's going to be a vector. However, we need to calculate the magnitude of that velocity. And then finally, we're going to create a vector, and the vector is going to be called the velocity vector. And we're just going to set the values in here to 0, 0. And then beneath this, we're going to create a global function, just a function that will generate a random velocity vector. We're going to do this by returning a velocity vector. So SF vector 2F, and that's the return type. And we're going to go and put generate vector. Oh, there we go. What we're going to do is we're going to create a temporary velocity vector. I'm going to call it vel for now. And in this we'll do vel.x, because we have an x component. It's going to get a bit complicated, this line here, but it's nice, short and simple, and you should be able to understand it. So we're going to type double rand divided by rand underscore max, and then we're multiplying that by the square root of the max vel mag. And when I'm done with this function here, I'm actually going to show you what this function does in a more mathematical term for those of you who may be more interested. And now we're going to set the y part of this as the square root by the max vel mag subtracted by the new the vel dot x component, so our new velocity vector x multiplied by itself. And then the line here, and then what we're going to do is I'm going to throw a more complicated thing at you guys. I'm going to create a definition, and we're we're going to call this the binary step rand. And what this little definition will do is it'll generate a random number, and that random number will either be -1 or 1. And we're going to do this by doing rand again, modulo 2. So now it's just going to give us 2 numbers. And then we're going to do -1. And what this is doing, this is generating, it's either going to create a 0 or a 1. It's going to multiply it by 2, so now it's created 0 or 2, and it's going to subtract 1, so it's giving us -1 or 1, nothing in between. And what we're going to do now is we're going to do val.y multiplied equals to that bin step rand. And then what we want is we want this new velocity vector not to just be up or down. What does I'll run it and show you what I mean. Oh, I forgot, it's because this must return a value, so we're just going to return val. So what we want is we want this ball here to go sort of like in this direction. But if we leave this function at how it is now, the ball will either go, it has a chance of just going straight up, straight down, back. So what we want to do is we want to create a range that'll sort of allow it to go sort of more in this direction. Not this, but sort of like primarily focus on sort of this kind of behavior. So to do this, what we're going to do is going to create an if statement here. We're going to do if the val.x is less than or equal to 2, return generate vector. And this function it looks more complicated than it is now, but simply what this definition will do, so I'll just get this one out of the way first. When the C program is compiled, it'll replace this bit here with this. So these are literally the same thing. But what this function will do is let's just go into Desmos quickly and it'll be easier to show you. So you have the equation of a circle here. And let's set it to 60. So a vector is basically, in a 2D world, a vector can just be expressed as a straight line to a point. So what we want is a velocity vector heading in sort of this direction. Okay. So what we can do here is we can actually say, hey, I want x greater than 2. So what we've done here is we've actually created a vector who can never be sort of off in this direction. It'll always favour to go in this direction when it's generated. It can only go in that direction. And what this function does here, that generates the vector, is it spawns a random value for the x coordinate. So I don't know. So let's say it gave a value of 4 for the x value. So that's 4 squared plus y squared equals 60. Ignore these lines for now. And then all it does is rearrange it to solve for y by doing square root of 60 minus 16. And that would give us a y value of 6.6 for the y component of our vector. That's all it does, and then it just multiplies it by either -1 or 1 randomly. That way we can get purely random vectors, or as random as they get in terms of computer. That's all this one does. So if we get a value less than 2, I don't mean to open the Microsoft store, so if we get, say, an x value that's, say, here, it's going to say, no, I don't want that. Let's call this function again until we get it, and then if we do get it, basically return this value. And that's all it's doing. And then what we can do here is we can set the velocity vector equal to generate vector. Then every iteration we can do ball dot set position, set vector to f. I'm just going to jump down a line here just to make things just sort of easier to read. And it's going to take an x and a y position. So we're going to do ball.get position this time. X, we're just going to add velocity vector to dot x. And then we're going to do the same for the y. And we're not, the more sort of understanding of how you may make a game have probably noticed I don't have any delta time, but this game is so sort of simple and not hardware demanding that you really wouldn't really notice any jitter anyway. So if we do this, we should see the ball moving. And there goes the ball. But you notice he's just gone off the screen, so that's no good. So what we're now going to do is we're now going to create our collisions. So to do this, just beneath here, we're going to do void collision. This is where stuff's going to get a bit more complicated, but we're going to do circle shape, then we're going to put an asterisk. And that's making this a pointer now. So that's a pointer. So that's, instead of referencing the actual, I guess, ball, we're referencing its position in memory rather than just a reference of the ball. And you'll see why in a second why this is important to do. And just to make life easier later on, we're also going to do rectangle shape, paddle, and we're also going to do sound for our sound effects that we're going to add later on. So in here, what I'm going to do is I'm going to get this running on a separate thread. So that way, every basically tick, it's not going to sort of interrupt the runtime of the game. Just check this, and it's going to make it kind of more efficient and hopefully reduce the effect of sort of jittering due to not having any delta time. So to do this, we're going to do while true if ball get position dot x is less than or equal to 0. When we did. Then what we're going to do is we're going to do if the velocity vector dot x is less than 0, and you'll see why I'm doing this in a second. Velocity dot x multiply equal -1, and then velocity vector equals generate vector. So actually what we can do is we can get rid of this line here, because it doesn't matter, because we're just replacing it, so we can actually get rid of that line. And we're going to increment our points too. And then we've got a new if statement here, if ball get position dot y is less than or equal to 0. And we're going to check our velocity. So if our velocity vector dot y is less than or equal to 0, then we can just multiply that velocity vector by -1. Multiply equal -1. And what this multiply equal multiply -1. Oh, we have an error somewhere. Lovely jubbly. Sorry, the first time round, I just got thrown off by that error. The error is because we don't have the y. There we go. What these if statements here are doing is they're basically saying, has the ball's velocity changed so it's no longer heading in that direction, and has it reflected? If we don't have this, what you'll notice is a weird sort of jittering effect where the ball's hit the surface but it hasn't quite realized it's hit the surface yet, so it multiplies and changes the velocity, and then it says, hey, we're still at the surface, and it sort of jitters and then bugs out and then comes off again, but it's like a braking potential. Just by adding this here, stops any weird little things. And what we can do is we can copy this, and we can just do that and that. But on this one down below here, we're going to change it so if it's greater than 900 minus 2 multiplied by ball get the radius. Then we're going to change it again, but this time, just flicking through our notes here, we need to check if the ball's velocity is greater than or equal to 0, because obviously we don't want to glitch it out. And then on this one, similar thing again, but this time with the x position instead of the y position. And we're going to be checking if its position is greater than 1000. So it's greater than 1000 minus 2 multiplied by the ball's radius again. And just checking everything in my notes is nice and sound. Here we go. So what we want to do, so at this point here, it doesn't matter if the ball hits the wall or not, because it's hitting our right wall, which means the ball is dead. Rip the ball. So what we're going to do is we're going to reset the ball's position, and we're going to reset its velocity. And we can't do dot because we're pointing to a point in memory, we're not actually referencing the ball directly. So hopefully we should see, oh, what's happened there. All part of the process. So let's have a look what's happened here. So we said, is the ball's velocity, I believe that should be greater than. Let's have a look. Oh no, we've had the same thing happen here as well. What have I done wrong? I'm running this off of printed paper notes. So I've actually printed the working code. And I've written a load of notes alongside them. It's not very easy actually. I definitely should need to set up my second monitor. So the ball get position X should be less than or equal to 0, so this one up here is working. If it's less than 0, that one's working good. Less than or equal to 0, so this one. I'm going to do that. Less than 0, multiply equal minus 1. Yep, multiply by equal minus 1. If the ball get position on the y is greater than 900, that is correct, minus 2 times the ball radius, and the velocity is greater than 0. Well, that shouldn't matter too much. Yep, everything here looks fine. So it looks like here, I've just realized why it's not working. We haven't called the function. Oh no. To be fair, it's 20 to 12. It's basically midnight. So what we're going to do now is we're going to set up the threading process. Threads, it's basically running it on a separate core of the computer. This is a really sort of easy way to put it, but it's not technically true. So typically my computer has 12 threads, 6 cores. Each core has 2 threads on my computer, at least anyway. And by running it on a separate thread, there we go, we're kind of allowing it to run in parallel to the main game, and that can help us free up a lot of processing power and make the game run smoother. So what we're going to do is we're going to call SF thread. We're going to call this the collision thread. There we go. And what we're going to do is we're going to do std bind. So we're using the standard library, the IOStream library in the function here. Forgive me, I'm tired. I don't know too much about std bind, so you will have to sort of excuse me for this. So I can't really talk much about it. And we're going to do player, not player paddle, sorry, paddle. And that's going to ask for another one as well. It's going to ask for sound, but we don't currently have any sound, so we're just going to do and sound. So what we're going to do is we're just going to create a quick little sound effect here. The sound effect won't reference anything, and we're just going to call it sound for now. And he's happy about that, or she, can't be too careful these days. And we're going to do collision thread dot launch. Here we go, now it should work. There we go, and it hits that, velocity vector resets. There we go. We can run this for hundreds of times, and it'll never start off going this way or going straight up and down like that. Also, if it hits the paddle by chance, it's just going to go straight through the paddle at the moment, as we haven't actually programmed any collision with the paddle. So that'll probably be our next step in the collision function. So just frantically flicking through my notes here. Here we go, we can get the paddle collision up and running. So here we go, so we're going to do, this one's going to be more complicated than the one before, as it's quite a few nested if statements, so bear with me. So ball.get position dot y is less than or equal to paddle get position dot y plus 100. And ball get position dot y is greater than or equal to the paddle. You know this is going, get position dot y. That's the first if statement complete. There's a few, so bear with me again. And the ball dot ball get position dot x plus 2 multiplied by the ball's radius is greater than or equal to 920. 920 here is just the value of where it's the fixed position of where the paddler is. So it's basically the leftmost face of the paddle. And the ball get position dot x. The last bit here is less than or equal to 950. So that means if it makes contact with the paddle. So this will help prevent any sort of bugs where it can glitch into the paddle. So we've basically created a collision box around the paddle. Finally, we can do the velocity vector check. So if, didn't mean to do that. If velocity vector, if the x component of the velocity vector is greater than 0, then we can do just the velocity vector multiplication minus 1. And then to add some challenge to the game, we're going to do the max velocity magnitude plus equals 3. And then we don't want that getting too fast and out of control, so we're going to set a limit to the maximum velocity vector by doing maxval mag greater than 150. And if it gets bigger than that, we're just going to set it back to 150. This will just help prevent any weird kind of behaviours. And I've got the X. Lovely jubbly. So this bit of code here will now handle any collisions with the paddle, which is just what we want. Well, that's good and all, but how do we actually control the paddle? And that's a good question. So to do this, get this, we're setting up another oh no, don't select all of it. So to do this, we're going to set up another function. This one's going to be void, so it's not going to return anything. Just like the one up here, it's not returning anything. And this is going to be controls. And to do this, we're going to hand in the rectangle. Once again as a pointer. And we're going to do paddle, just to name it. And we're going to do while true again, because we want this running on a separate thread. Now, what we need to do is we need to sleep. And I'll show you, I'll just program this in quickly now. But once we have this function up and running, I'll show you why it's important we put this sleep function in. But just to briefly put, we're going to do 1000 over 60, so it will update roughly about the same time that the screen updates. Mine's a 60 Hz monitor, so hence why I've done 60 here, but you should really try and put your monitor's refresh rate in, just to get a better experience. So what we're going to do here is we're going to do if the SF keyboard is key pressed, SF keyboard up. Oh, it would help if I did the double. There we go. Then we're just going to update the paddle's position. Paddle, not paddle, paddle. Paddle dot set position SF vector 2F. And now I want to update the Y position instead of the X position. So we're going to do paddle get position, this is just the X position basically, dot X, and then paddle get position dot Y plus this times, because we're going up, oh, so, minus, sorry, because we're going up and the very top of the window is basically 0, so as we're going up we want to basically subtract from our value. I'm going to put 8 because 8 is a nice speed to sort of start at. And then we can basically copy this if statement, sorry not function, we can copy this if statement, and instead of up we can do down. Ooh, deleted a bit too much there. We can do down, and instead of subtracts we can do add. And I believe that is everything set. Let me just check my notes. Paddle set position. Oh, what we do need to do though is add a collision check, because we can't let it go, the paddle go out of bounds, because that kind of just breaks the game. So we're going to do if paddle get position dot Y is less than or equal to 0. We can just call, well, let's see, is it in there? Yeah, we can just call continue, and that would just skip this input. And we can do the same. I think this will work. This is sort of a different technique than I've done in my notes, and I'm kind of experimenting here, but it's good to experiment. Y is greater than or equal to 800. Continue. And what continue will do is means it will just kind of just skip the rest of the loop. And then we can create a control thread. So thread control std bind once again, and this time we're going to be referencing controls. Oh. And the paddle. And we're going to do control dot launch. If we run this, we should have a moving paddle. There we go, and there we go. As you can see, I can't go out of bounds either. So that's the game nearly done. We're just going to add a few more things, including a sound effect and a point counter. So there are some things I want to do as well just before we move on to those, and that's at the end of these while loops, what we want to do is we want to do delete. We're going to call on this one paddle. And we're also going to delete ball, paddle and sound off of the collisions thread. So delete ball, paddle and sound. And that's going to help prevent any memory leaks, because C++, when you reference pointer, you're referencing the memory address. So what we've actually done here is we've basically recorded the memory address and we're referencing that memory address. So it's very important we delete it to prevent things called memory leaks, and memory leaks aren't very good. They can end up creating basically hell in programming terms. And then at the end here we can just end those threads. So we can do collision thread dot terminate and control dot terminate. That's just going to end those threads. But now we can just move on to the sound effects. So that's awesome. Apologise for these little breaks. I'm just here to flicking through my notes basically. So what we want to do is we want to create a thing called a sound buffer. And we're going to use this buffer to load our sound. And to do that we're just going to do if buffer, if not, sorry, so not is just the exclamation mark, so if not buffer dot load from file. And if we just hop into our code along, so if we, as you can see, we're in sort of our setup page. If we go into Pong, you see we have a bounce clap, and that's what we want to try and put in here. So we're going to do as a string bounce dash clap dot wav return -1 as we have an error, and we just want to exit as quickly as possible. And then what we're going to do now is we're going to do sound dot set buffer. And then when we have our collisions, we want to play that sound. So we're going to do sound play. Don't want to do it here because the ball's died. Sound play. And we can just copy this for the rest of them. We only want to play it once. So if we do it now, there we go, there's our sound effect. Lovely jubbly. And now we have our points, so what we're going to do now is we also want to tally our points basically. So as the ball's died here, we want to reset our points too, so we're going to do points equals 0. So now it's time to use our std, so we're going to do std os string stream, and we'll call that ss. And then we're going to do ss dash dash points. And then we're going to create a font. And then same as before, if not font dot load from file. And this one here is called robotomonobol.ttf, so I'm just going to copy that one in, it'll be a bit easier. So if it's failed to load that one, same as before, return -1, as that's an error code X as status. But we don't have to worry about those. Now I can create our text part, so sf text, then text, text.set fonts equal to font, text.set position, I'm going to hiccup, never mind, bit of a tease that one. I'm going to cough that apparently. Set factor to f, and that's going to be 500 minus the text.get local bounds width, sorry, divided by 2, and 15. And then we're going to set the size, set character size equal to 60, and that's in pixels by the way. We're going to set the color to white, and we're also going to set the string. And to do that, we're going to do we're going to do ss.str. That's basically saying our ss string, our os string stream, and we're just going to get the string from that. And if I've done everything properly, that should be all done properly. And then finally, we just draw it all on. So we're going to do window.draw our text. And then, obviously at the end, well not necessarily obviously, but at the end of every sort of loop we want to update our SS string, otherwise we end up with quite a funny sort of glitch happening. So just to do that, we do that, and then we set the string. Right at the bottom. I believe that is Pong made in 154 lines of code. So let's have a look. There we go, and if we die, resets back to 0. So that's been Pong in SFML. I don't know how long that's been. Let's check OBS. So that has been 41 minutes. So I've made Pong, single player Pong in 41 minutes. Isn't too bad. It's optional to have the red bar at the end. You can, add it if you'd like to. But I mean, yeah, that's been Pong. 40 minutes. Beat that coding train. And all of this is running on 3 different threads. You have the main thread, you have the collision thread, and the control thread. And if we just want to get it a bit better, we just build it in release mode instead. Oh, it's going to take a bit to load. There we go. And we'll get sort of like a better, more reliable performance this way. But I mean, if you guys have liked this video, please do make sure to like and subscribe. It means a lot. If you want to see more as well, definitely do that because it will just encourage me to make more. Yeah, I'll leave links to my GitHub. I'll leave links to my GitHub, as well as the SFML sort of tutorial setup page, so you sort of know how to set up if you want to set up on your own, as well as a link to another YouTube video that shows the perfect way to set up SFML, but you shouldn't have to do it if you just download directly from my GitHub. But I mean, could have got that one. If you enjoyed the video, yeah, please like and subscribe, I suppose, leave a comment as well, show me where you got. I basically always respond, because I don't really do much in my life. I believe that's all, so have a good one guys. That's been Pong in 41 minutes. Yeah, sweet. There's going to be, just a final remark, there are going to be more videos being made. I'm going to start working a lot more in C++. I used to do Java quite a lot, but I kind of want to learn C++ for more hardware related tasks involving Arduinos and stuff. So that's my final note, as well as just suggest like coding things that you guys want me to do, and chances are I'll do them. But yeah, like, comment, subscribe, and I'll see you guys next time.